I am, as Lauren said, Lewis Cummings, worked on site for the last 17 years, and I've been involved in projects for the last 8 to 10 years in some way, shape or form. I've been on sub-project manager on the SAV project for the last 3.5 to 4 years. I aim to cover the following topics today: a bit of background and high-level project scope, the project delivery methodology that we've used to date, a bit on contract strategy, some challenges and risks we've faced and are facing, how we've mitigated some of those, some of the lessons learned and how we're implementing them, and then how we fit with current and future projects on the Sellafield site. High-level project scope, in line with the NDA's focus on high hazard risk reduction, we're diverting 6 active ventilation feeds away from existing stacks and piles within what's called the separation area. This is going to be achieved through the running of approximately 3,500 metres of stainless steel ducting, ranging in size from 800mm diameter to 1800mm diameter. And it's going to be run along new pipe bridges that we're going to build and existing pipe bridges within the SEP area. You can see the duct runs are shown in blue on the diagram behind me, and they are complete in the new plant room, 120 metre high stack, substation and plant monitoring rooms in the top right of the diagram. The design life for this project is 100 years, and this is to fit with sustaining decommissioning within the SEP area to take it back to ground level effectively. Delivery methodology. The SEP project to date has been delivered in line with the company's previous methodology known as FEL, front-end loading, as the new Sellafield gated methodology is being rolled out and has been implemented company-wide. As you can see, FEL is a fairly standard gated process with 7 gates, 4 of which are mandatory, shown in red. To date, SAV has passed through all gates from SOP to FEL 3 due to the nature of the project, size and complexity. We achieved FEL Gate Note in January of 2003 and passed through FEL Gate 3 into project execution in November of 2007. We're currently on schedule to go into active commissioning in the January of 2013 and final handover to plant in June 2014. Just a bit on the contract strategy, a couple of slides on this, how we've run through to date. Between FEL Note and FEL 3, we utilised what was then the multidiscipline site-wide contract on a framework agreement, a reimbursable framework, and that was to develop the project design from inception through to a reference design that we could then go out to tender pre-FEL 3 for the main design and build contract. Towards the latter stages of the MDSW contract, we let a series of advanced enabling works on NEC3 option A fixed price. Some of the contractors engaged, as shown there, AMEC, Shepley Engineers, Stubbarts, PPS Electrical and Norwest Halls, Soil Engineering, now known as Vinci or Vici, I think. And I'll expand on those a little bit later in the presentation. At FEL 3, we let the main D&B contract on an NEC3 option C target cost type arrangement, and the winning tenderer was Doosan Babcock Energy Limited. Doosan's are utilising a number of key subcontractors, some existing to site, some new to site. Kia's for all civil works, Shepley Engineers for the inner separation and structural steel erection, Beerham's for the stack and the stack slip forming, Balfour Beatty for all electrical instrumentation and control installations, and Senior Hargreaves for duct manufacture and installation on the site. The main contract scope is to further develop the reference design where required and construct and install the inset pipe bridges and pipe bridge structures, the structures which run outside of the separation area, construction, installation on the substation, plant room, stack and stack monitoring rooms, all the required electrical supplies, control and instrumentation to and from donor plants inside the plant room. In addition to this, Doosan's will be carrying out up to inactive commissioning, with active commissioning being carried out by Sellafield Ltd commissioning and operations teams. Challenges and risks. We have faced and overcome and are facing a significant amount of challenges and risks on the SAV project. And I'll just run through a few of the key ones because our risk register is quite large. Like I said before, we're tying into existing active ventilation feeds coming from plants with nuclear inventory. The vast majority of these feeds had never been shut down before, full stop. So a major challenge was the development of a methodology and a safety case to enable us to shut these down, allowing us to install our tie-in pieces in very constrained and specific operational shutdown windows, which if we missed them, the project end date would have been knocked way out. Subsurface ground conditions. Where we were looking to construct, there was a distinct lack of historical knowledge on the subsurface ground conditions, especially when we were drilling pile, or going to be drilling piles to a depth of 36 metres into bedrock. And the desktop studies that were available could only take us so far. And in addition to that, a project which has determined the ground conditions across the site was at a similar stage in the FEL methodology to us at the time as in FEL 3, so we had no warranted data from them. Early in the design stage, in that pre-FEL 3, it was identified that the main site outside of the separation area, the electrical infrastructure couldn't supply us with the required amounts of power we needed to open up all of our work faces. So we had to look into this quite seriously. High number of stakeholders, it's been a bit of a common theme through all the presentations so far, but because of the nature of the project and the amount of boundaries it crosses on the site and interfaces we've got a large number of very influential internal stakeholders ranging from operational plants to service providers, with interest also from the regulators, the EA, the NII, and of course the NDA. The main SAV site is quite a small site, especially when all the construction work fronts are opened up, and this poses us with traffic management and material storage issues which the construction and project team need to adapt to maintain construction activities. Within the SEP area, it's a very congested site. We're surrounded on all sides by operational plants with nuclear inventory, and we will be affecting them, be it plant movements or people movements. So we need to maintain those relations in order to minimise impact on both on us and the operational plants. As the bulk of our work is within the separation area, there's structures in there that we're going to be utilising and tying into that date back to the 1950s when the site was originally constructed. And seeing as our design life is for 100 years, it poses a significant challenge with regards to sustainability of the old structures and maintainability as well if we're encasing them in any way, shape or form. A little bit on mitigation now. We've mitigated some of the previous risks. Like I said earlier, early in the design stage, it was identified in the risk process that we had some very high risks that would affect our project end date. So it was decided to let a series of risk mitigating enabling contracts with a view to preserving the project end date. Some of these that were let were we had a significant site investigation works campaign outside of SEP, we drilled a series of 46 metre deep boreholes with window sample locations both in and out SEP ranging from 2 metres to 6 metres deep, with a view to finding out the geological information and information with regards to waste disposal for the spoil that we're going to be generating. Strengthening of existing pipe bridge structures within the SEP area, because we're going to be utilising these structures to effectively hang our new ductwork off. We needed to strengthen them to make them man enough to take the loads we were going to be imposing on them. The tie-ins, the installation of the plant tie-ins had to be done early, as I said, otherwise the project end date due to scheduled operational shutdowns would have been unachievable. In groundworks in the SEP area, along the same vein as the pipe bridge structures, we had to modify and strengthen the foundations of a significant amount of the existing pipe bridges in SEP so that they could take our imposed wind loadings, and we installed a series of brand new foundations where our new structures are going. Installation of a construction substation on the main site to mitigate the risk of the electrical supply, so we could actually open up all of our construction work faces. And we had a series of service diversions that we had to make around the site, such as telecoms and drainage and things like that. As you can see, these works more or less coincide with the challenges and risks on the previous slide. And with the benefit of hindsight, had we not let them and identified them as early in the risk process, the project end date would have been affected quite categorically. Just some photos now. That's just an example of the strengthening of the foundations, the above ground, and it goes to about 3.5 metres in depth. Significant volumes of concrete in the separation area where no excavation had been done for quite a significant amount of time. That was the 11 kV substation, and the next few photos are 6 of the installed successful plant tie-ins on the active lines. We have, like I said, we're in the execution phase now, and we've started physical construction on the site, so a few nice photos of the site. We've procured and manufactured a significant amount of the ductwork. Shown there's the 1800mm diameter ductwork, which you can't really get a picture of it there, but you can walk right down the middle without touching your head on it. It's quite large, between 9 and 12 metre sections, so the fairly large piece of kit. That's the site setup, the main site outside of SEP, where the stack and the plant room and everything's going to be. That shows some of the traffic management arrangements which are evolving as we progress, as more work faces open up. This was one of our performance-based indicators, the installation of the construction substation on the main site. The main substations A and B for the plant room. Piling operations, which have now been completed, just shows the piling rig and one of the rebar cages. There's actually 2 of those connected together that goes down one shaft, and there's 12 in a circle for the stack foundation. And most recently we've started erecting the physical steel framework for the main plant room building, which is well and truly underway. Just a few headlines, lessons learned that we've learnt as a project and we've implemented from other areas of the Sellafield site. As I've said, the early risk identification and placement of risk mitigating contracts is essential. It's worked very, very well for us, and it's key if you've got a tight project end date to preserve, as we've got some very, very key follow-on projects that we're enabling. Open, honest attitude with stakeholders is essential. We've fostered this from the beginning, and it's enabled us to forge trusted links with both internal and external stakeholders, which has led to a minimum of disruption to the project work to date. The next 2 what we've learned from other big ventilation projects on the Sellafield site. First one being the construction and commissioning interface and overlap. As soon as your detailed construction schedule is available, you need to minimise the amount of construction and commissioning activities that overlap. It's hard to do, as many people will attest to, but to enable or to ensure a smooth transition into commissioning when you're going to pick up a lot of your defects and faults, you need this to happen so your commissioning can be carried out in a systematical, logical order. This is quite a big one for us. Close out construction works in systems and not physical geographical areas. As if you close your construction works down in areas, for example, first floor of a building, then commission it, second floor of a building, then commission it, you're going to miss valuable information and data on systems that span between the areas, such as electrical instrumentation, control, flow measurements, things like that. And just to put it into perspective, the longest duct run on the South project is approximately 1 kilometre in length. So we've got a whole host of dampers, electrical instrumentation equipment, cabling going back to donor plants, and this installation work falls over 3 different work packages on the structure. So we've got it scheduled so that these are all going to knit together to allow the entire system to be commissioned at once, so we get all the valid data that will then enable us to go on to active operations and hand over to the end owner. The fit with current and future nuclear projects, touched on these a little bit previously. We're a major enabler for 2 key high hazard risk reduction projects on the site. We're a part of a large programme of works. One being the demolition of the GEW stack that we're diverting feeds away from. I apologise for lecturing, we're not allowed to use building numbers. And the demolition of the remaining HFG pile, which is due to come down. So we're currently maintaining their start dates on construction by preserving our completion dates. Due to what we're doing in the ventilation project, we're providing a ventilation capacity in excess of what's already available in the separation area. And what that's going to do is sustain the current decommissioning activities within SEP and all of the future requirements which are planned out from cradle to grave. And we've also built in additional capacity into the plant room to cope with any potential unknowns that come our way. So this is the main enabler to getting the separation area back down to ground level effectively. And that about wraps it up. Thank you for being patient with me.